An atom is the smallest piece of an element that still retains all of the properties of that element. So as we begin talking about biology and we talk about molecules that are going to be involved inside living cells, we do need to start off with a look at atoms and their overall structure and properties. So an atom is going to be made up of smaller particles, and those smaller particles are protons, neutrons, and also electrons. If we talk about where these happen to be arranged in the atom, in the very center of the atom, we're going to have some particles located here, and I'm showing these in pink. And I'm going to put a little plus sign on the top of each of those. And the reason for that is that these are going to represent the protons, and protons have a positive charge to them. So each proton is going to have a +1 charge. Also located here, right next to the protons, is going to be some particles that are pretty much the same size, and I'm showing them in blue, and now I'm putting a little 0 on top. And my reason for that is that these are going to have a neutral charge, or we could say no charge to them, and these represent the neutrons. So all of these particles together that I've shown so far represent what we would call the nucleus. So right here in the center of the atom is what is known as the nucleus. The nucleus is really just a grouping or a huddling together of the protons and the neutrons. And when we look at all of those grouped together, that is going to have an overall positive charge to it, because the protons are contributing a positive charge and the neutrons aren't really contributing anything to the charge. Now, the other particle that we haven't yet talked about is going to be the electrons. And the electrons I'm going to draw as little E minuses, and I'm drawing them kind of far away or at a pretty good distance from those particles that happen to be located in the nucleus, because the electrons are located quite far away. And these electrons, they do have a negative charge to them, and they're moving very fast all of the time. So since they are moving very fast all of the time, a lot of times we think of them as creating this cloud, as I've just drawn it here, this cloud that surrounds the nucleus. And this cloud that they create has a negative charge to it. So the electrons are going to have a negative charge, and they are moving very fast all of the time. So we have these stationary particles in the center, which we're calling the nucleus. And then we have these really rapidly moving particles around the outside. If we talk about sizes, the protons and the neutrons, so all of these particles that we have on the inside, these are going to have a mass of 1 Dalton each. So they are the same as far as mass goes, and they're considered to be relatively large, really. And when we compare that to the mass of the electrons, I drew them tiny because they are small, and they are about 1/2000th of a Dalton. So it would really take 2,000 of those to make up or match the mass of 1 proton or 1 neutron. And when we talk about the overall mass of the atom, we don't even think about the mass that the electrons are contributing, because in the grand scheme of things, it really is negligible. So if we're talking about the atom's mass, we really just want to add together the number of protons and neutrons. So that happens to be what we call the mass number. So the mass number gives us an approximate mass, and this is going to be just adding together the protons plus the neutrons. And so if we were trying to determine the mass number of this particular example that I've drawn here, hopefully you can see that in this case, the mass number does happen to equal 7. So 7 Daltons would be the mass that we have here. Again, we're not considering the fact that we do have electrons that would contribute just tiny little bits on top of that. Another thing to point out here is that as I have drawn it, we do have the same number of protons and electrons. that might be the case. We might have examples where we have different numbers of them. Actually, we could have different numbers of each one of these particles. So we could have, 3 protons, 4 neutrons, and we might have only 2 electrons. So we definitely don't have to have the same number of each of the different particles.